Okay, so we're here with the Heron's proof, and I'm not going to say it's the best approach to it, but it's one that I'm taking. And what I want to point out is I give you a picture, and the picture is hopefully going to enable you to follow what's being done over here. So I want to point out what the picture is. The picture's over here, and I'll come back to it. But right now, and again, I will go to the whiteboard, but I want to talk about just being able to look at a picture and look at work and see how they relate to one another. All right. So the first thing up here is the triangle's perimeter. And I hope you realize it's just the addition of the three sides, and that would be A plus B plus C. With the understanding that this side over here is side C, that this is side C over here. Now, does that make sense to me? It does, because I'm looking at these triangles, by the way, and there are triangles there. I see three triangles, a big one, and then two subtriangles, where the base would be X and C minus X. All right, so I'm going to say that it makes sense. I got that part covered. The next thing says semi-perimeter. Semi-perimeter is half the perimeter. So I'm going to say makes sense, makes sense. All right. The next thing I want to do is the left subtriangle and see if that makes sense. Now, this is the left subtriangle over here. And what are they talking about over here? Let's go back. And they're talking about something. Oh, they're talking about the Pythagorean theorem. That makes sense. And it's going to be, it's a right triangle, by the way. X squared plus Y squared is equal to A squared, right? Makes sense. Let me show you where that is, right over here, right? Let's go to the right subtriangle. Let's look at that. And I'm looking at this one over here. And what do you get there? Well, I'd say, C minus X squared plus Y squared would be equal to B squared. Let's take a look at that. And where they got C minus X, plus Y squared equals B squared. Everything's just flowing from that picture. Right, the next thing I did was I expanded it, and it doesn't look too bad to expand. If you expand this thing, it's going to be B squared equals, that's a binomial, so it's going to be C squared minus 2CX plus X squared plus Y squared. And I do see that here. I see C squared minus 2CX, X squared plus Y squared. All right? Now, again, you may wonder, why am I doing this over here? And it may be pointless, by the way, but I'm starting to realize that I could probably take this thing, put on the other side, which would be 2CX, and then the right side, I'd get C squared plus B squared plus X squared plus Y squared, which is, I'm sorry, I made a mistake already. I got to erase that. So it's C squared, and I took away B squared. Sorry about that. All right? So I'm going to say this stands to reason. All right, next up. 2CX equals C squared minus B squared. And what's X squared plus Y squared? It's right over here. It's just A squared. All right? So I see where that's coming from. And then I solve for X. And what do you get over here? X would equal C squared minus B squared plus A squared over 2C. So this makes sense. All right? And then the part comes is, what do you do now? There's a variety of things you could do. Let's take a look at it. And I'm going to look at this thing and try to figure out what comes next. So I'm going to say at this point, it doesn't look that bad, but I guess I could solve this thing for Y squared. So I would write down A squared minus X squared is equal to Y squared. And again, you may look at this and say, I don't know why you're doing that. It can be done. And then someone says, could you solve for Y? Of course you could. Y is a positive number, and you'd get, if you did it, I'm not saying you want to do that, but you could play around. This Y equals, it's the root A squared. Whoops, that doesn't look right. A squared minus X squared. All right, if you want to do that. All right. Now, over here, I'm going to go the next step and write down what I'm seeing over here. So this is still Y squared, by the way. It's A squared. And then what do I get over here? The X is right over here. So I just put it down. It's C squared plus A squared minus B squared. Different order, by the way. And that's squared. I got that. All right. And then here comes the tough part. It even says it. To this thing. It's tough. All right. So what I want to do, I'm going to go to the whiteboard and try to figure that out. All right, try to figure out the factorization of it. And to do that, I got some work to do, and I want to go to the whiteboard to do it. And I'll open up the whiteboard and expand it out. And I'll tell you where I am. And I got to write down where I am. In other words, I lost my screen, but I'll sort of write down, I'm at the stage where y squared is equal to a squared minus c squared plus a squared minus b squared all over 2c, and this thing's being squared, all right? So, I'm going to say it does look difficult, but I think I could probably, maybe, at least get one fraction out of it, all right? I'm going to say the bottom would be 4c squared, and I'd get this over here. All right, I haven't changed that at all. Now I got to build that other guy up, and that's going to be 4, let's see, c squared, a squared. And this they said it's a tough part. I'm looking at this thing, and I'm going to say this thing definitely factors. Looks like it might be tough, though. I'm going to say 2ac, and then what do you get? You're going to get, let's see, plus c squared plus a squared minus b squared. And then you get minus c squared minus a squared plus b squared. All right? I'm kind of looking at that. I'm looking at, what they got over here, and it appears that maybe there's a factorization of the problem. So I'm going to look at this over here. And that looks like, well, it doesn't look that bad. It looks like a plus c quantity squared minus b squared. Let me see if that's true. You get a squared plus c squared, and then you get 2ac. Looks good to me. All right, let's look at the next one. And I'm still looking at this. All right, a little more complicated, isn't it? So I'm going to say, b squared. And then I'm looking at this thing over here, and I want to write down, it's really minus a squared plus c squared minus 2ac. I think I did okay there. So I'm going to say minus, it looks like a minus c squared now. All right, that's all over 4c squared. And again, they said this was a tough part, and I really do believe it's tough. So I'm going to factor these are difference of perfect squares, and you can get a plus c minus b. You're going to get a plus c plus b. And here you're going to get b, minus a plus c. And then you can get b plus a minus c over 4c squared. Now you may forget what this thing is. I want to go back to you. It's just y squared, by the way. All right? Again, I even say, what was that all about? I'm trying to derive Heron's formula. I know I'm getting sort of warm at this point, and I'm looking at this thing, and I want to remind you something. I want to remind you that we had this semi-perimeter S, and S was A plus B plus C over 2. Now, you could also call this P over 2 if you want. It really doesn't much matter. So I want to maybe rewrite this a little bit. And I want to see if I get that perimeter out of it. And let me see. And I'm going to put down A plus C plus B minus 2. This is A plus C plus B. Let me write this one down now. And I'm going to write down A plus B plus C minus 2A. Let's see how I did. Now, by the way, it's still over 4c squared. Oh boy, this is going to be a tough one too, right? A plus B plus C minus 2c. All right, not too bad. Oh, wait a second, I made a mistake over here, and I just noticed it. A plus C plus B, that's going to be minus 2b. Sorry about that. All right. I still want to, I'm looking for this thing over here, by the way. So, I guess I got to put something in, don't I? And let's write this down next. This is still y squared. I got the 4. And, I don't know, I guess I'll put these over 2. Maybe I don't want to put that one over 2, but I guess I could. Over 2, over 2. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So I got to put a 16 over here. And keep massaging. What do you get over here? You're going to get 16, but now I'm starting to recognize that this thing over here is that S thing. And you're going to get S minus B. Oh, by the way, this is still over 4c squared. Over here, this is just S. Over here, I get S, and then I get that minus 2a over 2, which is just simply minus a. Again, I'm looking at this. This is S. And this is going to be S, because this thing is S over here, and then minus c. I'm getting kind of warm at this point. So let's write this down. It's going to be 4. I'm reducing. And then you're going to get S minus A. I like to put things in order, by the way. S minus B and S minus C. And this is all over c squared. This is still equal to y squared, by the way. All right, still equal to y squared. Now, granted, someone says, where are you going with this one? We're trying to figure out the area, all right? And again, I hope you look back over that picture, and the area, right, if you remember what the picture looks like this over here, where the height of it was y and the base was c. And the area of that would be 1/2 times c times y, all right? So I'm going to clean this up a little bit. I'm going to write down y squared c squared. I can put the 4 over here too, by the way. And I get S minus A, S minus B, and S minus C. Again, I want to remind you that the S is this thing over here, all right? That's part of Heron's formula, by the way. And now what I'm going to do is, Heron's formula's got a root in it. I'm going to take the square root of both sides. I don't have to worry about plus or minus, by the way. These are all positive concepts over here. So what do I get? I would get 1/2 y c. Again, the square root of 4 is 2, so that's why it's 1/2. And I get the root over here, which is S minus A, S minus B, S minus C. Again, we just derived Heron's formula, by the way, and that's the area, and this is going to be area, by the way. Area of what? Of that triangle. We just derived it with the understanding that S is equal to A plus B plus C over 2, and the sides of the triangle are A, B, and C. And that's it. End of story. Thank you.